Design and checks for horizontal bracing elements. Capacity check for building cores. There are two different horizontal bracing elements to be considered during the design. First, the individual shear walls, and second, the building cores, consisting of a set of walls. This video will focus on the capacity check for the building cores. For more information about the shear walls, please refer to the previous video of this series. Each building core has a single design element, which considers and integrates the forces of the quad elements of all related walls. A cross-section is required for the capacity check and created by default. The capacity check is based on the integrated forces from the quad elements of all walls associated with a building core. Thanks to this new type of design element, a column-like experience for a collection of walls becomes possible. The calculation of the capacity is performed under consideration of the reinforcement, as specified in the cross-section editor. However, it is possible to define so-called core cuts to introduce reinforcement staggering along the length of the building core. The specific reinforcement configuration at each cut creates a temporary cross-section for the check, without having to recalculate the whole project from the start. Using the SSD template for building design seismic analysis from within Revit, the capacity check is already present in our project tree. Otherwise, it can be found in the member design group of the Insert Task menu. The General tab lists the available building cores. The viewer to the right shows the respective cross-sections. We are only interested in building cores Tier 2 and Tier 3 and 4, so we disable the first one. Load case table shows only load cases from the ULS fundamental and ULS seismic combination that store results for design elements. The default selection includes the relevant load cases for results such as normal forces, shear forces, and bending moments, and does not need to be adjusted. Next, we continue with the settings for the capacity check. This tab allows you to define so-called core cuts along the length of the building core, which enable you to adjust the reinforcement for the resulting segments. There are preset core cuts at the beginning and end of each building core. Unlike splitting up the core during modeling or adjusting the reinforcement directly in the cross-section editor, this approach does not require us to recalculate the model from the start. Instead, a temporary cross-section is used for the capacity check. The reinforcement is usually taken from the cross-section itself, but can be manually adjusted. For any but the bottommost core cut, a link to the lower cut can be established. We are going to create two new core cuts at elevation -4 meters and +3.5 meters to adjust the reinforcement manually in this range. The layout of the reinforcement element selected in the table is visualized in the viewer. I want to point out that the layout, for example the number or the spacing of the line elements, remains the same, and only the reinforcement amount gets scaled up or down. The same filter functionality as before helps with the input of the reinforcement. It is possible to copy and paste entries in this table. At the next core cut, the reinforcement is automatically linked again to the cross-section. On the final tab, we can adjust the level of detail for the created report. Descriptive texts explain what each level contains. By default, only decisive load cases and respective forces or results are listed in each table, but this can be increased to include all results. To the right, we can decide which capacity curves we want to include in our report. By default, both NM and MM plots are activated. I will also enable the capacity comparison plot to visualize the increase in the capacity due to the change of reinforcement. The report is created during calculation and can be accessed in the known ways, either through the ribbon on top or through the context menu. The result is structured by each building core. Let's focus on core tier 3 and 4. The individual chapters include everything from general information, over load case information and internal forces to the resulting capacity for each core. The materials table lists the concrete and reinforcement used in the cross-section. It is not possible to account for walls with different material strengths within one core. The layout of the reinforcement shows the rebar designations to account for readability of the report. The Analyzed Combinations table lists the decisive load cases, as well as the total number of load cases that were analyzed. If more information is required, we can increase the output level for this section. The load case combination table shows the internal forces of the building core design element, which represent the integrated forces of all walls involved at each level. The check table holds information about the resisting forces based on the acting forces of a certain load case and the reinforcement configuration for each level. The second last column gives us the information of the relative capacity.
The requested interaction curves get plotted for each segment of the building core. The NM plot, with the normal force on the vertical and the bending moment on the horizontal axis, holds the following information. A. The legend with the specific load combination and the related acting forces for which the curve is valid. B. The marker for the acting forces, indicating the relative capacity. C. The curve representing the capacity limit of the building core's cross-section. As long as the marker is within the curve, the capacity limit is bigger than the acting forces. The relative capacity, expressed by the ratio RD to ED, is bigger than 1, and the check is successful for that load combination. The MM plot is similar but shows the bending moment My on the horizontal and the bending moment Mz on the vertical axis. The curve is only valid for the acting normal force of the specific load combination. The effects on the building core's capacity on account of the adjustments to the reinforcement can be seen in the capacity curve variation plot. Each curve represents the capacity limit for a specific reinforcement configuration and is identified by the elevation of the core cut and the total amount of reinforcement.